Angles of elevation and depression. Let's learn something new. Objectives. Distinguish between angles of elevation and angles of depression, and use trigonometric ratios to solve problems. Nice visual there, showing the difference between line of sight, which forms an angle of elevation, and line of sight, which forms an angle of depression. Many real-world problems that involve looking up at an object can be described in terms of angle of elevation, which is the angle between an observer's line of sight and a horizontal line. When an observer's looking down, the angle of depression is the angle between the observer's line of sight and a horizontal line. Let's find angle of elevation, angle of depression in each of the figures. Angle of elevation first in number 1 is angle TSL. Angle of depression from the helicopter down to the building is angle FLS. Angle of elevation from the person up to the Ferris wheel is angle SWT. Angle of depression from the Ferris wheel down to the person is angle RTW. Let's do it again. Now this moose is looking at a house, and apparently the house with the tree that's a little bit tipsy is looking up at the moose. So angle of elevation is angle ABC, and angle of depression is angle DCB. Ooh, person and hot air balloon. Angle of elevation, he's looking up at the hot air balloon, is angle RPZ. Angle of depression, person in the hot air balloon looking down at the person, is angle WZP. Write an equation and solve. Show all work algebraically round to the nearest tenth. Angle of elevation from point A to the top of a cliff is 34 degrees, and it's already marked on the diagram. If point A is 1,000 feet from the base of the cliff, which is already marked as well, how high is the cliff? So that's what we're looking for. According to, or with respect to the 34-degree angle, what we're looking for is side that's opposite that angle, and this is adjacent. Opposite and adjacent's tangent. Tangent of the 34 degrees is x over 1,000. Multiply both sides by 1,000. Here we go. Put it in the calculator or put it in Desmos. The answer is 674.5 feet high. That is approximate height of the cliff. 6. Angle of elevation from point A to the top of the hill is 49 degrees. If point A is 400 feet horizontally to the peak of the hill, which is marked, how high is the hill? So that's what we're looking for. It's marked with H. That side's opposite. This side's adjacent. Tangent, again, a lot of these are going to be tangent. Tangent 49 degrees is h over 400. Multiply both sides by 400. Here we go. Graphing calculator. Desmos. Same answer. The hill is approximately 460.1 feet high. Number 7. A ski run is 1,000 yards long. There we go. Don't have the skier moving, maybe next time, with a vertical drop of 208 yards. Good thing we're not doing that. Find the angle of depression from the top of the ski run to the bottom. So horizontally, there it is. There's our angle of depression. It is not inside our triangle, but we know alternate and interior angles are congruent, so we can pull that X inside that triangle. It is not tangent this time. We have opposite and hypotenuse, which is going to be sine. So sine of our angle, which is x this time, is 208 over 1,000. To undo sine, we have to do the inverse sine of 208 over 1,000. Put it in your calculator, put it in Desmos. Doesn't matter. It's about 12.0 degrees. Degree sign's kind of low. It's okay. Here we go. Mastery Connect example. Horizontal distance on a survey map from the top edge of a river bank to the river is 85 feet, as shown in the diagram below. If the actual distance from the top edge of the riverbank to the surface of the river is 92 feet, which value is closest to the angle of depression? So that's what we're looking for right there. This is the hypotenuse in that right triangle. This is adjacent. So this is going to be cosine. So cosine of our angle, we'll call it x, is 85 adjacent over 92 hypotenuse. To undo sine, we do the inverse sine of 85 over 92. Graphing calculator, Desmos, whichever you want. We have A, 22 degrees, final answer. Number 2, angle of elevation. Okay, so this is a more complex problem, but let's stick with it. Angle of elevation from the top of tower X from tower Y is 32 degrees. So we do have that angle marked in there, but it's worded weird. It is from the top, no, angle of elevation, top of tower X from tower Y. I don't know why they wrote it that way, but they did. So this is what that means. If tower X is 60 meters tall, that whole thing, and tower Y is 42 meters tall, how far is the distance D, which is marked down there, between the base of tower X and the base of tower Y? Well, let's push that up so we have a triangle. We do need to know this side right here, opposite. So if tower X is 60 and tower Y is 42, if we subtract those, 60 minus 42, we get that little part of the triangle up there, the side opposite 32 degrees. Bring up our adjacent, which is D. Opposite and adjacent, tangent once again, and write our equation. Tangent 32 is 18 over D. D's in the denominator. Don't worry. Slick trick, those can trade places. So D is 18 over 32. Tangent of 32, oh my. Let's put that in our calculator. We can also put it in Desmos. Final answer, C, 28.81 meters. Number 3, angle of elevation from the base of tower X to the top of tower Y, 68 degrees, already marked on our picture. If the height of tower Y is 35 meters, that's already marked as well. And according to that 60-degree angle, or with reference to that, that is the opposite side in our right triangle. What is the approximate distance between the towers? Okay, so that's what we're looking for. That's the adjacent side. Let's call it X. So opposite and adjacent, yes, tangent again. Tangent 68 is 35 over X, no problem. Those two can switch places. X is 35 divided by tangent 68. Graphing calculator, Desmos, doesn't matter. We get about 14.14 meters. Okay, delta math example this time from her eye. Okay, the little bald stick figure right there, which shows 1.5 meters above the ground. So her eye is 1.5 meters above the ground. Madeline measures the angle of elevation to the top of the prominent skyscraper. Good thing she had a protractor with her. That is 49 degrees. Let's stick it in there. If she's standing at a horizontal distance of 179 meters, the 179 is marked, its meters will be okay. Let's see. We need to know the height, the entire height of the skyscraper. But in that triangle, X is what we're going to be calculating. And then we have to add that 1.5 on at the end. So opposite, adjacent, tangent, once again, comes to the rescue. Tangent 49. X over 179, multiply both sides by 179. X is 179 times tangent 49, graphing calculator. Add the 1.5, or in Desmos, do the 179 tangent 49, and I just went straight to adding the 1.5 on, because that's how high her eye was, and we get about 207.42, because it says this time round to the nearest hundredth. Delta Math is picky. They tell you where to round to. Make sure that's where you round to. Number 2, hot air balloon. Elizabeth's up there somewhere in that hot air balloon. Maybe I should add a stick figure. Doesn't matter. Angle of depression is 30 degrees to a landmark. That is, looks like Eiffel Tower. Way teeny weeny. 361 feet away. You would think it'd be bigger than that. No big deal. What is the measure's vertical distance? So that's the X there above the ground. So we can do alternate interior angles if we want to. Angle of depression is the same as the angle of elevation. If someone were at the Eiffel Tower looking up at the balloon, it'd be 30 degrees. And from the balloon looking down to the Eiffel Tower, that's 30 degrees as well. Anyways, we have opposite and adjacent. So tangent comes to the rescue again. Tangent 30 degrees is X over 360. Multiply both sides, whoa, by 361. Oh my. X is 361, tangent 30, graphing calculator. Desmos, doesn't matter. Balloon's vertical distance above the ground is about 208.4 feet. Number 3, Philip is flying a kite, holding his hand a distance of 3.75 feet above the ground and letting all the kite string out. He measures the angle of elevation from his hand. See, protractors are so handy. 33 degrees. If the string of the kite in the hand is 110 feet long, how many feet is the kite above the ground? Okay, in that little triangle, X is not the entire length. So once again, we would have to add 3.75 on to that value of X. X is opposite. This is hypotenuse, not tangent. Opposite and hypotenuse is sine. Sine 33 degrees is X over 110. Multiply both sides by 110. 110 sine 33. Graphing calculator. Add the 3.75 or Desmos. And the final answer to the nearest tenth. Delta Math's picky. 63.7 feet. And we have now concluded angles of elevation and angles of depression.